Welcome to the Verboten Manuscripts, episode 23. Everybody is looking for answers in the stars, but what if the answers are already reaching out to us? The year was 1899. On a high plateau in Colorado Springs, a lone figure stood silhouetted against the gathering dusk. This was Nikola Tesla, a man whose mind crackled with the same energy he sought to tame. He had built a laboratory here, far from the constant sounds and distractions of New York City, to conduct experiments on a scale the world had never seen. His goal was nothing less than to create a system for wireless global communication. He dreamed of sending power and information through the air, across oceans and continents, without a single wire. It was a vision that placed him decades, even a century, ahead of his time. A prophet in a world not yet ready for his revelations. At his Colorado Springs facility was a colossal magnifying transmitter. This wasn't just a simple coil. It was an electrical behemoth designed to generate millions of volts and send powerful electrical disturbances rippling through the Earth itself. The centerpiece was a massive spiral coil, 52 feet in diameter, that looked like something from a science fiction tale. When active, it could create artificial lightning bolts over 100 feet long, creating a spectacular man-made thunderstorm. Tesla wasn't just playing with sparks, he was trying to understand the resonant frequency of our entire planet to tap into its natural electrical properties, testing the transmission of his equipment and to eavesdrop on the natural electrical symphony of the cosmos. Tesla designed a special radio receiver. It was an incredibly sensitive device for its era. A marvel of engineering he called a terrestrial stationary wave detector. This instrument was tuned not just to receive signals from his own transmitter, but to listen for any electrical disturbance in the atmosphere or beyond. He believed that the Earth itself was a giant conductor, and by carefully tuning his equipment, he could pick up signals from any place on Earth, or perhaps from even further away. Tesla spent countless hours in his remote laboratory, meticulously recording his observations. The air was thin, the nights were cold, and the work was isolating. Yet, he was driven by a powerful curiosity, a desire to peel back the layers of reality and see the universe for what it truly was. He was charting unknown territory, both electrically and philosophically. He was not just an inventor, he was an explorer. His laboratory was his ship, and the vast, silent expanse of the cosmos was his ocean. It was here, during one fateful night of listening, that he would encounter something that would forever change his perspective on our place in the universe. One night, while monitoring his sensitive receiver, Tesla detected something extraordinary. Amidst the familiar crackle of distant thunderstorms and the steady hum of terrestrial noise, a new pattern emerged. It was a series of faint rhythmic signals. 3 pulses repeating in a clear pattern. 1, 2, 3. They were orderly, precise, and utterly unlike the chaotic static he was used to. The sounds were so deliberate, so seemingly intelligent, that Tesla's mind immediately raced to a stunning conclusion. He felt a deep, intuitive certainty that he was listening to a message from another world. The signals were not random. They had a mathematical quality to them, a structure that implied purpose. Tesla recognized logical signal patterns immediately. He ruled out known natural sources. Solar flares and atmospheric disturbances didn't behave this way. He considered the signal might be from another inventor on Earth, perhaps another scientist, Guglielmo Marconi. But the nature of the signals seemed too strange, too alien. Tesla was overwhelmed by the thought that he heard the first greeting from another civilization. Could he have been right? Humanity's first contact with an extraterrestrial intelligence made in a remote Colorado lab in 1899? Most scientists today believe there are more plausible, natural explanations. One theory is that Tesla may have detected the radio waves produced by Jupiter as it moved through its powerful magnetic field. Another possibility is that he picked up the signals from a pulsar, a rapidly spinning neutron star that emits beams of radiation like a cosmic lighthouse. These objects were not discovered until decades later, so to Tesla, their perfectly timed pulses would have seemed completely artificial. This story highlights a fundamental challenge in the search for extraterrestrial intelligence, or SETI. The universe is filled with strange and wonderful phenomena, many of which we are still just beginning to understand. A signal that seems artificial to one generation might be revealed as a new type of natural cosmic event to the next. Tesla's experience was a powerful lesson. Separating a true message from the vast, complex, and often misleading symphony of cosmic noise is one of the greatest scientific challenges we face. His mysterious signals were the first of many cosmic puzzles that would force us to question what is natural and what might be something more. The quest to find a signal from an alien civilization is often compared to searching for a needle in a haystack. But this analogy doesn't quite capture the scale of the problem. A better one might be searching for a single specific needle in a haystack the size of a galaxy. The number of potential star systems to listen to is staggering. The range of possible frequencies is immense, and we have no idea what a real alien message would even sound like. We are listening for something unknown, using our own limited understanding of physics and communication as a guide. Over the years, astronomers have had their own Tesla moments. In 1967, graduate student Jocelyn Bell Burnell detected a signal that pulsed with incredible regularity once every 1.33 seconds. It was so precise that the team half-jokingly labeled it LGM-1 for Little Green Men. It seemed too perfect to be natural. However, after discovering more of these signals from different parts of the sky, they realized they had stumbled upon a new class of celestial object, the pulsar. What first appeared to be a message was, in fact, a natural cosmic clock, a discovery that earned a Nobel Prize. Another famous false alarm was the WOW signal, detected in 1977 by the Big Ear radio telescope at Ohio State University. It was a powerful narrowband radio signal that lasted for 72 seconds and appeared to come from the direction of the constellation Sagittarius. It perfectly matched the profile of what scientists expected an artificial interstellar signal to look like. An astronomer, Jerry Amon, was so impressed that he circled the data on a computer printout and wrote, "Wow," in the margin. Despite numerous attempts, the signal has never been detected again, leaving it as one of the most tantalizing mysteries in the history of SETI. These experiences teach us to be cautious. Our universe is cleverer than we are, and it constantly produces phenomena that challenge our imaginations. Every strange new signal must be rigorously tested. Could it be interference from a satellite, a microwave oven on Earth, or a previously unknown natural event? Scientists must act as cosmic detectives, painstakingly ruling out every possible natural and man-made explanation before they can even begin to consider the extraordinary possibility of an artificial origin. The haystack is vast, and the search requires patience, skepticism, and an open mind. In 2007, astronomers found a new kind of cosmic puzzle. While looking through old data from the park's radio telescope in Australia, graduate student David Narkovich and his supervisor, Duncan Lorimer, found something bizarre. It was a single, incredibly bright burst of radio waves that lasted for just a few milliseconds, less time than it takes to blink. And, it was immensely powerful, releasing as much energy in that tiny fraction of a second as our sun does in an entire day. This event, named the Lorimer Burst, was the first confirmed fast radio burst, or FRB. It came from a location far beyond our own galaxy, billions of light years away. For years, many astronomers were skeptical. The bursts were so brief and so rare that some thought they might just be glitches in the telescope equipment. But then, more FRBs were found by different telescopes around the world, confirming they were real cosmic events. The mystery only deepened. What could possibly generate such an enormous amount of energy in such a short time? The bursts were clearly coming from deep space, as the signals were dispersed, meaning different frequencies arrived at slightly different times. A smearing effect caused by traveling through the sparse matter between galaxies. The discovery of FRBs opened up a brand new field of astrophysics. Scientists began a frantic hunt to find more of these enigmatic signals and to figure out what causes them. Most FRBs are one-off events. They flash once and are never heard from again. This makes them incredibly difficult to study. By the time you point another telescope at the location, the show is over. It's like trying to photograph a single, unpredictable lightning strike in a storm that covers the entire sky. You really have to be looking in the right place at exactly the right time. However, the game changed in 2012 with the discovery of an FRB that repeats. This repeating burst allowed astronomers to pinpoint its location to a small dwarf galaxy about 3 billion light-years away. This was a huge breakthrough. Knowing the source galaxy meant scientists could study the environment where the FRB was born. They found it was a dynamic region of active star formation. The leading theory today is that many FRBs are produced by magnetars, young, highly magnetized neutron stars. But even this explanation doesn't fit all the data perfectly, and the puzzle of FRBs is far from solved. To solve the mystery of fast radio bursts, we need to detect a lot of them. We need a telescope that can watch a huge swath of the sky all the time, ready to catch these fleeting flashes whenever they appear. This is where a revolutionary new instrument comes in. The Canadian Hydrogen Intensity Mapping Experiment, or CHIME, located in British Columbia, Canada. CHIME doesn't look like a traditional telescope. It has no giant steerable dish. Instead, it consists of 4 massive half-pipe-shaped antennas, each 100 meters long, that look kind of like snowboard ramps. CHIME is a digital telescope with no moving parts. It scans the entire sky above it every single day by processing an enormous amount of data, about 7 terabits per second, which is comparable to all the mobile data traffic in the world. Its wide field of view makes it a perfect FRB finding machine. While other telescopes might catch one by chance, CHIME is designed for it. Since it began operating, it has detected thousands of FRBs, increasing the total number of known events by a huge margin. It has become the world's leading instrument for studying these mysterious signals. Once CHIME or another telescope detects an FRB, the real detective work begins. Scientists analyze every property of the signal. They look at its brightness, its duration, and the precise way it is smeared out across different frequencies. This dispersion measure tells them how far the signal has traveled, giving them a rough idea of its distance. If the FRB is a repeater, astronomers can use a network of telescopes around the world to triangulate its position with incredible accuracy, pinpointing the exact galaxy and sometimes even the specific region within that galaxy from which it came. The data pouring in from KIME is so vast that human scientists can't possibly sift through it all by themselves. That's why they are increasingly turning to artificial intelligence. Machine learning algorithms are trained to recognize the specific signature of an FRB amidst the constant torrent of cosmic and terrestrial noise. These AI systems can spot potential candidates in real time, flagging them for human follow-up. This partnership between giant, sensitive telescopes and smart algorithms is accelerating the pace of discovery, bringing us closer to understanding the true nature of these powerful cosmic blasts. While most scientists believe FRBs have a natural origin, such as magnetars, some are exploring more exotic possibilities. One of the most prominent voices in this discussion is Avi Loeb, an astrophysicist from Harvard University. He argues that we should not be so quick to dismiss the possibility that some FRBs could be signs of advanced alien technology. After all, an event that releases the energy of a sun in a millisecond is so extreme that it pushes the limits of our known physics. What if we're not looking at a natural event, but at an engineering project on a galactic scale? Loeb has proposed that a powerful repeating FRB could be evidence of a power source leak. Perhaps it is a beacon intended to announce civilization's presence to the cosmos, or more fantastically, he suggests it could be a side effect of a propulsion system for a light sail. An alien civilization could be using powerful focused beams of energy to push giant spacecraft to near the speed of light. The FRBs we detect could be the fleeting moments when one of these beams sweeps past our line of sight. This idea sounds like it's straight out of science fiction, echoing science fiction warp drives of Star Trek, which require immense energy. This brings us back to the central challenge. How do we tell the difference between nature and technology? One clue might be the complexity of the signal. A natural signal, even a repeating one from a pulsar, is usually quite simple. An artificial signal, on the other hand, might contain layers of information, a coded message hidden within the pulse. Scientists use sophisticated computer programs to search for patterns, repetition, and modulation in signals that might indicate an intelligent source. So far, the FRBs we've seen appear to be broadband noise, with no obvious message encoded within them. The search continues, fueled by the profound implications of what we might find. Every strange signal from the cosmos is a gift. Most will turn out to be new and exciting forms of natural phenomena, expanding our understanding of the universe. They might reveal new physics or introduce us to objects we never knew existed, but we keep listening because one day a signal might arrive that is different, a signal that is undeniably artificial. Until that day comes, we will continue to point our telescopes to the sky, inspired by pioneers like Tesla, always wondering if we are truly alone. If you enjoyed exploring these cosmic mysteries and the legacy of Tesla with us, don't forget to like this video and subscribe to our channel for more deep dives into the unknown. Your support helps us keep searching the stars for answers.